we have given implication. Let's put that x squared plus 4 is our p, and x equals 2 or negative 2 is our q. We have implication p imply q. First, we have to write converse. When we have implication p imply q, the converse for this implication is, let me write this, is q imply p. So we will have, first we have to put q, so this is x is equal to or negative 2 imply x squared equals 4, because x squared plus 4 equals 4 is our p. It's our formula. Now we have to write contrapositive of the following implication. We have p imply q, contrapositive, is not q imply not p. So we will have to negate our q statement and have to negate our p statement. So we have, let me write this. This was our converse. And now we have to find contrapositive. So we have not q. Q is x equals 2 or negative 2 imply not p. P is x squared equals 4. We can rewrite x equals 2 or negative 2. So we have negation of x equals 2 or x equals negative 2. This is equal exactly what we have here. X equals plus or minus 2. So x equals 2 or x equals negative 2 we have. And this implies that x, and we have negation of x squared equals 4. It's negation of equation we have. So we have x squared is different than 4. And here we have this junction. We have x equals 2 or x equals negative 2. This is negation of this junction. And for negation of this junction, we use De Morgan's law. When we have, for example, negation of r or s, this is equivalent from De Morgan's law that not r and not s. So we will have not x equals 2 and not x equals negative 2. And this implies x squared is different than 4. When we have negation of equation x equals 2, so we will have x is different than 2 and x is different than negative 2. We can put this whole expression in parentheses because this conjunction implies that x squared is different than 4. This is our contrapositive of our implication p imply q. This is my solution.